Dear students, now in this class I am going to explain Bayes theorem and its applications. First let us learn Bayes theorem. If E1, E2, E3, etc. up to En or n mutually exclusive events exclusive and exhaustive also exclusive and exhaustive in a random experiment and A is an event associated with this random experiment with this, then and in this with such that P of A is not equal to 0, then P of Ek by A, Ek oblique A is equal to P of Ek into P of A oblique Ek by sigma P of Ei into P of A oblique Ei. I is equal to 1 to n. For k is equal to 1, 2, 3 up to any number of keys up to n. Now here E1, E2, E3 up to n are mutually exclusive events. Now you can take a diagram like this. This is total sample space. Now let us divide this into n. This is E1, E2, E3 and so on. Last one is En. These are n mutually exclusive events and exhaustive also. Means no other events are there in that. Except these, no other events are there. Union of all these things is total sample space. Now there is one more event in that experiment, that is A. One more event is there, that is A. Now, what is this? This part, this is E1 intersection A or E intersection E1. This is A intersection E2. This one is A intersection E2. The last one is A intersection En. Now here, what is S? Here E1 intersects or else Ei given Ei intersection is A is equal to 5 if I is not equal to Z. What's the meaning of this? If I is not equal, it may be E1, this may be E2. No intersection. It is null set. Similarly, E2, E3, E4, E5, like that, all are mutually exclusive. No common sample points are there for any two events, E1, E2 or E2, E3 like that. Now, in that case, what is S? S means the union of all these E1, E2, E3 up to En. That is E1, union, E2, union, E3, union up to union En. Simply we can write it as union I is equal to 1 to n Ei. Now A is equal to, what is A? A can be taken as the intersection of A and S. S is the total space. In that one, A is the common part of A and S. So I will take it as A intersection S. But S is union of EA. A intersection union EA. I is equal to 1 to N. This is A intersection E1 union A intersection E2 union, etc. Last one is A intersection EN. This part is A intersection E1. This part means up to here. A intersection E2. This part is A intersection E3. Now you have got like this. Now you can write it as union now. Now that is equal to union of I is equal to 1 to N A union EI. A union EI. Now P of A is equal to probability for A. P of this plus P of this plus P of this, everything. So that is P of A intersection E1 plus P of A intersection E2 and so on plus P of A intersection EN. But simply you can write it as sigma I is equal to 1 to N P of A intersection EA. But previously there is conditional probability was there. What is P of A by B? A oblique B. P of A intersection B by P of B. And P of B by A is B oblique A. Again P of A intersection B by P of A. Now you can write this. Now if you take cross multiplication, what is P of A intersection B? P of A by B into P of B or P of B into P of A by B, or the same thing as P of A into P of B by A. Now you can use either this or this. Now here P of A, you consider this as P of A intersection B, for example. That is P of B into P of A by B, you can write. This is equal to sigma I is equal to 1 to N P of EI into P of A by EA. By using this one, first one, P of A intersection B is P of B into P of A by B. This is also P of A intersection B, P of B into P of A by B. Now you take this as one. First result. Now we have to write the value of this one. P of EK by A. P of EK by A. Now how do we write this one? This is P of A oblique EK into P of EK. Or you can write the reverse order also. P of EK into P of EK into P of A by EK. By P of A. Sorry, this one can be written as, first of all, P of A by formula we have to use. P of EK intersection A by P of A. By using this formula, P of A oblique B is P of A intersection B by P of B. Now, use this formula. P of A intersection B is P of B into P of A by B. Now this is P of Ek. P of B into P of A by Ek. A oblique Ek. By P of A. Now, this is equal to, but what is P of A value? Is this one. In place of P of A, I have to write this value. P of Ek into P of A oblique Ek. By P of A value, I have to write from this one. This is P of A value. Equal to sigma I is equal to 1 to n P of Ei into P of A oblique Ei. So that is the value of P of Ek by A. But here you have to write K is equal to 1, 2, 3 up to n. Now this is the probability. It is given that an event A is happened. In that one, when A is happened, what is the probability for E3? That is P of E3 by A. You will get from this one. Suppose when A is happened, what is the probability for E2? That is P of E2 by A. We have to put K is equal to 2 like that. So that is the base theorem. Now let us see some applications of this. Now let us take this problem on base theorem. 3 boxes. B1, B2, B3 contains the balls as per the following table. Box, white, black, and red. B1, B2, B3. 3 boxes are there. 2, 1, 2, 3, 2, 4, 4, 3, 2. If a die is thrown, if it gives 1 or 2, box 1 will be taken. B1 will be taken. If 1 or 2 turns up, B1 is taken. If 3 or 4 turns up, B2 will be taken. If 5 or 6 turns up, B3 will be taken. After choosing the box according to that, the one ball is drawn from that. After choosing the box, one ball is taken from that, and it is noticed that the ball is red. What is the probability that it comes from B2? Second box. Here, the question is, the toss a die is thrown. If 1 or 2 comes on that die, they will take B1. They will choose B1. If 3 or 4 turns up, B2 will be taken. Second box will be taken. 5 or 6 is there, then they will take the box 3. After choosing the box, they will bring one ball. They will take one ball from that box, and it is noticed that the ball is red. What is the probability that it is from second box, B2? Now let us consider P of B1 first. Probability for getting box 1. To get box 1, 1 or 2 should come on the die. Probability for 1 or 2 on the die. So that is, what is the probability for getting 1 or 2? 2 numbers out of 6. That is 2 by 6 equal to 1 by 3. Similarly, P of B2, some other numbers, but probability is same. Another 2 numbers. Similarly, P of B2 is equal to 1 by 3, and probability for box 3, that is P of B3, is also 1 by 3. Now, let us find out. Let A be the event of getting a red ball. Let us take that event as A. Event of getting red ball. What is P of R by B1? That is probability for a red ball from the box 1. P of R by B1. How many balls are there? 2 plus 1 plus 2. 5 balls are there. Out of the 5 balls, 2 are red. So what is the probability for red ball from the first box? 2 by 5. P of R by B2. That is probability for red ball from the second box. How many balls are there? 3 plus 2 plus 4. That is 9. Out of that, 4 are red. So it is 4 by 9. P of R by B3. That is probability for red ball from the third box. So how many are there? 4 plus 3 plus 2 means 9. 2 are there out of 9. That is 2 by 9. So these are P of R by B1, P of R by B2, and P of R by B3. Now let us find out the probability for red ball from second box. P of B2 by R. P of B2 by R. What is Bayes' theorem says? P of EK oblique A is equal to P of EK into P of A oblique EK by sigma I is equal to 1 to n P of EI into P of A by EI. That is the formula for EK by A. Use that formula for B2 by R. Now this is P of B2 into P of R by B2 by this one, P of B1 into P of R by B1 plus P of B2. This is summation up to 3. 1 to n means here n is 3. P of B2 into P of R by B2 plus P of B3 into P of R by B3. Now let us substitute the values. What is P of B2? P of B1, P of B2, P of B3 are all are equal to 1 by 3. So it is 1 by 3 into P of R by B2 equal to 4 by 9 by P of B1 into, that is 1 by 3 into P of R by B1 is 2 by 5 plus P of B2 1 by 3. P of R by B2 is 4 by 9 plus again 1 by 3 into 2 by 9. Let us simplify this. 1 by 3 is common in both numerator and denominator. Take 1 by 3 common. 2 by 5 plus 4 by 9 plus 2 by 9. Cancel 1 by 3. Remaining things. 45 is LCM for denominator. 18. This is goes 5 times 5 into 4, 20. This also goes 5 times 10. So this is 4 by 9 into 45 by 48. So that you can cancel this by 5 times and this by 12 times. So ultimately the answer is 5 by 12. I'll explain one more sum. 3 boxes, again B1, B2, B3 are having the balls as per the table. This is B1. Here also 3 boxes. This is white, black, red. 1, 2, 3. 2, 1, 1. 4, 5, 3. The balls are like this. One box is randomly selected. One box is selected randomly, selected at random. And a ball is drawn from that. Drawn from that. And it is noticed the ball is red. The ball is red. Find the probability that the ball is from B2. Here also, as in the previous case, P of B, because the box is selected at random, we may get any one of those 3. So probabilities, they are equally likely events. That's why probability for getting any box is 1 by 3. So we know that P of B1 is equal to P of B2 is equal to P of B3 is equal to 1 by 3. Now let us take R is equal to event of getting red ball. event out. Now let us consider the probability for getting red ball from box 1. That is P of R by B1. How many balls are there in the first box? 1 plus 2 plus 3, that is 6. 3 out of 6. That is 1 by 2. Similarly, probability for red ball from second box. 1 out of 4. 1 by 4. Probability for red ball from B3. 3 by 3 plus 5. 8 plus 4. 12. 3 by 12 means 1 by 4. So these are the probabilities of R by B1, R by B2 and R by B3. Now, what is the question? What is the probability that the red ball from box 2? That is P of probability for red ball from box 2 is equal to P of B2 oblique R. B2 oblique R. B2 A is equal to here according to this formula. So this is P of B2 into P of R by B2. Denominator P of B1 into P of R by B1 plus P of B2 into P of R by B2 plus P of B3 into P of R by B3. Now let us substitute the values. P of B2 is 1 by 3 P into R by B2. P of R by B2 is 1 by 4. In the denominator, P of B1 is 1 by 3. P of R by B1 is 1 by 2 plus 1 by 3 into P of R by B2 is 1 by 4 plus 1 by 3 into 1 by 4 again. We can take 1 by 3 common in the denominator and cancel it. By 1 by 3 into 1 by 2 plus 1 by 4 plus 1 by 4. Cancel 1 by 3. That is 1 by 4 by 4 is LCM. 2 plus 1 plus 1. 4 by it is. Okay. That is 1 by 4. This is 4 by 4, 1 you will get. That is equal to 1 by 4. ఆ చదువులమ్మ